Sometimes a substitution needs to be done, much like the chain rule and derivatives. Integrals can have an inside function and an outside function. For example, if we want to find the area underneath this 2x plus 7 curve, if we want to integrate this, we would have to make a u substitution. We could say u is equal to 2x plus 7, and du is equal to 2x dx, because we use the chain rule. Then du divided by 2, oh, my mistake, that's just a 2, not a 2x. Du is equal to 2 dx. Du over 2 is equal to dx. So then we can plug this back in. Sine of u du over 2. And from the last video, the integral of sine was minus cosine. And then divide that by 2. And then we can undo the substitution. If we were given some sort of bounds, like 0 to pi, for instance, for 2x plus 7, we could plug in values for x and find out values for u. But I'll do that some other time, maybe. Sometimes we could use substitutions where things cancel out. For example, if u is equal to x squared, then du is equal to 2x dx, or du is equal to du over 2 is equal to 2 dx. No, sorry, x dx. And these cancel. And then we just have the sine of u over 2 plus c, or the sine of x squared over 2 plus c. There is another formula that is a little different. It's kind of like the chain rule or the product rule in reverse. So this is known as integration by parts. If we differentiate a product, then we get f prime g plus g prime f. And if we want to integrate a product now, we, integral of u dv is equal to uv minus integral of v du. What this means, u is a function and dv is a derivative of a function. So then we write that we have, and we integrate, we have a product of uv. So an example would be, let's say we have x squared e to the x dx. We can let u is equal to x squared and dv is equal to e to the x dx, or just e to the x. Then du is equal to 2x and v is equal to e to the x, because of the nice property of e to the x being its own integral and derivative. Although if the x and e to the x were changed to e to the 2x, things would definitely change. But e to the x is, its own integral. So by the formula, we have x squared minus dv, x squared e to the x is uv minus the integral of v du minus integral e to the x du and then we have that, and then we would have to do it again. This time let u equal x, du is equal to 1, and again dv is equal to e to the x, and that means v is equal to e to the x. So that gives us x e to the x minus e to the x, or just simply e to the x times x minus 1. And remember, that's getting multiplied by minus 2. So then our final integral would be x squared e to the x minus 2 e to the x times x minus 1 plus c. And we can actually pull out the e to the x times x squared minus 2 times x minus 1 plus c. And we can multiply that out, but it doesn't really matter. That's the basics for integration by parts. It's sometimes you have to do the process a few times until the integrals don't really until the process stops. It's just a process.